Right, one. All right, so I'm gonna hit Command K to clear my screen.
I had to restart my profile to make it, or restart my terminal to make it work.
That should, if it got into your profile, that's a way to do it. You can also just explicitly run your profile again by going source space tilde slash dot bash underscore profile. So that will execute your profile again, and if those aliases are there, then you should see it defined like that.
Oh yeah, that worked. Thank you.
Is that good? Is that good for you, Jonathan?
Yeah, it's all running fine now.
Sweet, sweet. Okay, excellent. All right, so all right. I think we're about ready to get started again. Let's see where. Yeah. Okay. So I guess I shouldn't ask who's not here yet, huh? Let's go ahead and jump into the. Unless there are any other questions about Bash or Linux that we've covered so far. Anybody's environment not working as far as those aliases? We're going to need to use those, so I want to make sure that that's in place for everybody. So, okay, basic Linux and shell. Review that. Got our aliases, got our objects unpacked. So now we can actually start getting into the repo and looking around. Okay, so as I had mentioned before, the .git repo is, or the .git directory is the repo. That is everything. That's your, you know, what your head is currently pointing at. It's also all of your history. It's branch pointers, such as you may have, you know, pulled down from your remote. It's all there. If your remote went away, you would still have your entire repo with you and all of its history. And you could reconstitute, you know, something remote if you wanted to by pushing to a new location. So let's look and see how it's laid out a little bit. So we're in the repo right now, learning-git. You've been working with head, whether you know it or not, and you can see what that is by doing rev parse, which is short for revision parse, and you see this big, long, ugly string. I think it's 40 characters or thereabouts. So, so what is that? Well, if you go down into objects, first notice that whatever your head is, take the first two characters. For me, it's you know, FC. My notes here are going to be a little bit different because head is going to change, you know, since I've last put these notes together. But the basic idea is that this head corresponds to a place in, actually just ls, I won't cd. So fc. And then you see a file there that has the rest of, it's basically named according to the rest of that long, ugly string, you know, starting with the third character, 2, 2, 2, 3, and so on and so forth. And so basically your head is stored, or what your head references is stored in this objects directory. This is the Git database. down here in this objects directory. Or if it was packed, it would be in that pack file, which Git would know how to parse as if it were the objects directory. So let's explore how this thing came to be, right? Let's try to make one. Actually, that's what we're going to do. The next step here, storing objects. So Git is it's a content addressable file system that implements version control. So what do we mean by content addressable? So let's demonstrate that by an example. So let's have some content. Hi there. And let's put it into just a text file. This is, nothing Git. This is just basic bash and, file manipulation. So there's our file. And now I'm going to use a low-level Git command called hash object. Should make a point. You won't normally use hash object, but this will show what Git does to files when you pass them in. So this thing is the hash of the content of this file. What does that mean? It's basically an algorithm that goes over the entire contents of the file and comes up with a unique number, unique to that content specifically. So notice that head is different up here than what I showed in my notes, but this hash object is identical. Anytime you do this, you're going to get the same content is going to produce the same hash every time. There is a very, 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 very small chance that it wouldn't, but it's so small we don't have to worry about it, basically. So this thing that we just produced is called a Shou for short. It's represents or it's an abbreviation for secure hash algorithm. And it used to be used for security, but it's not as secure anymore as it used to be because of computer speeds increasing and people getting better at cracking it. So it's not good for security, but it's still great for Git. Although they are working on a newer version that uses a more secure Shou, but it's so fundamental to Git that they haven't actually got it 100% working yet. So this is good. This is plenty good enough for us. So now is this thing in our Git repo? Let's check. All right, go down into Git objects. And if it's there, we should see a directory with 4.1. Okay. And then something with C36. So 4.1 is there, that's good, but nothing there that matches C36. So we produced the Shou, but we haven't actually stored it anywhere. So in order to do that, we have to give hash object a argument -w for write, and then try it again. Let's do a -l. See a little better. So yeah, there it is now. Okay, C36 just created. Yeah, just a couple minutes, just a minute ago. So that's us. So now we've actually stored we've stored content into our Git database without going the normal git add, git commit route. It's there, right? We could actually put it in a commit if we wanted to. One more thing we could do is to kind of see, since it's in the database now, we can use things to look at it from a database perspective, the Git database. And so here's another low-level command called cat file, which you also will never use in normal life. And you can use it to investigate objects in the database. So in our case, we can say 41C36, or even just 41C3 should be enough. And so cat, shows contents. So there it is. There's the contents of our file that it pulled out of the database. And just to jump ahead a little bit, we can also see what kind it is, what kind of object. So that's our, by default, hash object creates blobs. Okay, so anyone want to take a crack at describing the relationship between a Shou and a Git repo object? Silence is okay.
Well, so a Shou is a hashing algorithm, right?
Yeah.
So we are hashing the contents of a file line by line probably and getting a hash output.
Yes, we're getting the hash based on the contents, exactly. And actually, it doesn't matter. Lines don't really matter. It's just whatever it's the byte stream of the file. So you can get a hash out of an image as well as you can a text file. It just takes the bytes and runs it through the algorithm. That's actually how some browsers will handle, like when you are doing web development and want to expire the cache in the browser, you can name your JavaScript or your images by appending this a SHA to the end of it that's based on the contents of the file. And so then every time you change your file and push it up, then basically the browser gets instructed to ask for a different file because now the contents have changed. If it's the same file, the contents will be the same and the cache will still be valid, so the browser won't have to refetch it. So it's handy in places besides just to get database, but it makes it one of the nuances is that if you have maybe files in completely different directories that have the same contents, they'll use the same SHA even if they have a different file name, because notice here the file name is not part of the content. So there in fact is no file name here. It's just this SHA that is that it's referenced by. So we'll get into how Git handles file names in a minute, but it's if it's the same content, it's going to be the same SHA. You count on it. You can't tell what the content is from the SHA, but you can tell that it's the same. If you get the same SHA back. Okay. Any questions so far? All right. So now let's go ahead and put it in. So if you've done this, if you've got hi.txt here, go ahead and commit it the normal way. How would you do that?
Git commit. I'll get that.
Right. Git add first. All right. Git status. Oh, let's remove that error file. We don't need that. And we can, of course, if we should have Git GS there for us as an abbreviation for Git status. So I will also put Git alias is .sh back like it was for now. So yeah, we got our new file. And then yes, then git commit. Okay. So what SHA did I just create for the commit? Anybody have any guesses on that?
The BFEA.
Okay. How would you find out the full SHA? So that is the SHA that went in. So what does our head correspond to now?
The BFEA.
Right. Exactly right. And we could look at the head, the full head, by using that rev parse. That'd be one way we could do it. We could also look at, there's a git ref log, which kind of shows you what you've done most recently, which doesn't really show the full SHA, but it does give you, you know, it keeps track of where you've been, basically, or where head has been. So that's another way. And it's just a SHA. It's a commit SHA, but it's still just a SHA, so we should be able to go look at it and find it in the Git database, right? So what directory should we look in under Git objects?
Yeah.
Yeah, exactly right. And yep, so there's another way to find it, right? There's the rest of it down here, just like we see with the git rev parse. Okay, so so let's go ahead and let me show you this cat file command here a little bit more. So you can use cat file, and you can give it shortened SHA abbreviations if you want. Should eat those just fine. Okay, so there's what's in there. You can also see what kind of SHA it is if you wonder still. It tells you that it's a commit. So everything from there that's highlighted is part of that that commit SHA. So so what did we commit? Who remembers what we committed?
Well, I don't see like the object that we committed, right? Or is it the tree, or is it something else?
So the tree is on the trail to that object. I'll say that. So you could, and it you know, pretty clearly is also a SHA. So you could also cat the contents of the tree as well. So let me give you guys a couple minutes to go hunting around for that hi.text, given what I've given you so far here, and as well as, you know, we know that the hi.text has to be that thing that we hashed, right? It's got to be, when we find it, it's got to be this, because that SHA has to be the same for that content, because that's what, you know, hi dash there SHA's out to, if you will. Here's kind of where we're at this point. If somebody's able to see it, go ahead and shout out what you did. If you're able to find the hide.txt.
So I did the git cat file -b C16C, which was my tree, and it showed me the full directory.
Okay.
-b C16C. It might differ from yours though. I'm not sure. Yep, that's it.
Okay.
And there we see hide.txt.
And there it is. Very good. So we're sort of backing our way into these objects, but thus far we've encountered the blob object by just doing a hash object on hide.txt. We encountered the commit object by just doing a commit, ironically enough. So there's that, and then we observed this tree object here, which turns out to contain the blob that we're interested in that's under the commit. So we're sort of seeing that, the way Git thinks about its data, it builds a graph of the content of the versions, if you're talking about a commit, by stringing blobs and trees and commits together. So that's what we're going to be exploring a little bit more of, is the details of that. So before we get into that, just let's poke around in the Git directory a little bit. I'm going to go ahead and CD in there. I'm actually going to clear the screen first, avoid confusion. So now we're down in this section here. So okay, so a bunch of different things. We've seen the objects directory. There's this head file. And we've been working with heads, so that looks like that might be something interesting. So we can, in Linux, you can use the command file to kind of take a guess at what kind of file a thing might be, right? You can do that. You can do it on directories. It tells you that. So that's useful because if it's binary, you don't want to go ahead. You don't want to cat it to the screen because you're going to mess up your terminal. Maybe have to, start a new terminal. So this kind of tells you whether you can cat it or not. And because it's ASCII text, we're like, oh, okay, let's go ahead and try that. And this is the contents of head. So, which is interesting because if we do the rev parse, we get, the Shou. But if we just cat the actual contents, we get this guy. So the implication is that the rev parse is using this information here, but it's not stopping there. So this is what's called a symbolic reference. So we can also go and look at the file that it refs, under refs, and it's also ASCII text. We can do a cat bang dollar. And now we see where that Shou came from, how the rev parse got there. Basically it followed that symbolic reference all the way down to, resolving it to a Shou. So that's how a head gets stored. It's not always a symbolic reference, but it almost always is. You can actually set head to other things, but I'll hold off on that for a moment. So what about refs? What's in here? Okay, remotes. Origin. Origin also has a head. I'm not seeing a master in there. That's interesting. ADOG. Maybe because, I don't know why, actually I don't know why I'm not seeing a, by the way, when I'm in ADOG, I can use Q to get out of it. I can also like use up arrow and down arrow. I can use spacebar to go forward a page at a time, or B for back to go back a page at a time, or return also goes forward a line at a time. You can also use the J and K arrow keys, or I'm sorry, J and K letter keys. That's some free Vim for you there. All these things are, you can navigate the same way here you do it as you do in Vim for a lot of these movements. And then yeah, Q when you're done. So that lets you navigate around the history of your repo. But yeah, why isn't it master there? Try a couple of things. Well, let's just see what's in there. Cat, bang dollar, and I can also put other things on there like that. So refs, remotes, origin, master. Okay, so there should be a master there. Maybe it's something else Get has packed. It's possibly packed its references as well as its objects. So I'm just going to go with that theory for now and move on. You can see from ADOG that origin master also corresponds to a Shou ultimately. A commit Shou, I should say, because it's in this graph. All these commits here, or all these Shous here are commit Shous, just because they're in this graph. So, okay. Let's move on from that. Any questions from that thus far? Just a little bit of insight into how Git stores things inside of its repo. Actually, we could look at one more thing in refs now that I think about it. Heads. So okay, so here's basically a local reference. This master right here, the BFEA. So that's where that Git rev parse found what master was by looking in this exact directory here. What is master? Anybody have a insight into what is master in the Git framework? Like what kind of thing is it? Ed is pointing to it.
Is it the default branch?
Yes.
And you can name like the default branch something else. I know I've done that on accident before.
Yeah. Yeah. Master is, it's by convention the default branch, but there's nothing about Git really that, makes it special. It's just, we think of it as special just because, if you come from other source control systems, there are special branches like that. But as far as Git is concerned, it's just another branch. And it kind of, accommodates people's thinking about it being a special branch, but it really doesn't behave special, right? It's just another branch. You can rename whatever you want. You can configure your default branch as something else. There's nothing magical about master. So good to keep in mind. It's only special by convention, not by you know, its fundamental attributes. So yeah, it's a branch, and you know, all a branch is really it's a file with a SHA in it, a commit SHA in it, right? So if we were to say, where are we at? PWD. So go up a couple directories, .. /.. So ... references your parent directory, and a couple of them references 2 directories up. So now we're 2 up. And now we can say, you know, git checkout -b some new branch. Okay. So what just happened? What's different now about my setup than it was before when I did a checkout?
You create a new branch, you went to that branch.
Okay. And what would I see about head?
Head would point to some new branch.
Okay. Would it be a different SHA or the same SHA?
Same shop, haven't changed anything.
BFEA. Yeah, it's still the same SHA, isn't it? So, but if I went and looked at .git head, it's some new branch, right? And if I look at refs heads, some new branch, okay. It happens to point to the same SHA, but it's a different file, right? So that's kind of where you see the nuance of a symbolic reference versus an actual reference. So head's symbolic references change. Head is pointing to a different branch, but it actually, for the time being, is the same SHA because we haven't actually put anything on that branch. All right, if we look here, head used to point to master, but now it points here. You know, and you're literally looking at the symbolic file, you know, as it's represented in this graph, but the SHA is still the same. We're still right here. Makes sense to everyone? So I think we mentioned this already, but you know, we can check and make sure what kind of file we've got here with the -t option on cat file. And you don't have to give cat file an actual SHA. You can give it, you know, one of those symbolic references. You know, you can give it master. You know, you can give it, oops, can't give it a file. New branch. And of course, you know, you can -p it as well and see what actually contents of that commit are. So let's see, what are we going to go next? We said that the hash object creates a blob by default, so been there already. We added this. It's probably repetitive. I should take that out. Knowing what we know now. So let's focus in on the commit for a minute. So here we are, top of our repo. To get cat file, let me do a command K first. Git file -p head. Okay. Now you guys have done a commit, I believe, of hi.txt, right? So your head should be different than mine. So here's a question for you. Assuming that's the case, why is your head different from mine if we committed the same thing?
My guess would be that your there's other info that goes into that hashing algorithm.
Yeah. Yeah. So what would be different about the commit than my commit than your commit?
Like your username.
Yep. Exactly. Username. Parent would probably be the same. Tree would probably be the same because we're coming from the same repo. Comment might be different. These timestamps would definitely be different. Right? That's also part of the commit. So yeah, exactly. Your commit has all this stuff, and all that stuff gets run through that hash, and it all matters in what comes out the other side as far as a Shou. So yeah, so if I commit the same thing again, then I'm going to get a different commit. So like, you can do a git show to see what your commit was. And that just assumes head unless you give it something else, but you can actually give it an arbitrary commit Shou, and it'll show you the difference between that Shou and its parent, which is really, really handy. So yeah, this is my commit. So I'm going to show you a little magic here that I'll cover in more detail in the next section. But you can do a git reset to go all the way back to basically throw away the stuff that I did. So I'm going to throw away my commit of hi.txt. Actually, I'm not going to throw it all the way away. I'm just going to throw it part way away. So what I'm saying here is basically move head, or move the thing that head points to more precisely. Move my branch back to the commit before head, which is this parent, right? That's how Git knows what I'm saying here, is by this parent attribute on every commit. So and then I'll cover this in the next section, like I said. But reset by default moves the head, and it also moves the index, but it leaves the file alone that's in your workspace. So it's basically like uncommitting, but still having the changed content. So if I go git status, it's as if I had just created the file and had not added it or committed it yet. So let's do that again. And keep in mind what the previous head was. Starting with BFEA, okay. And then a new file, just do the same. So committed the same thing, but yeah, different. Got a different Shou. Oops, -B. Yeah, so it's important to keep in mind. I got confused about that early on when, I thought I didn't catch on what was going on when I was creating a commit, and I just would naturally assume that putting the same content into source control would give you the same result, but that's because I didn't understand how Git was doing things. So this is what's going on, is that hashing algorithm of this content. But it stores it the same ways it does the other objects, the same ways it does a tree or a blob. It goes to the same place. In fact, I'll say this, and then we'll take another short break here. This BFEA is still there. right? So I can go back to it if I want. If I just decide no, that was fine. I'll show you how to do that next session. But I think that's important in the sense that if you really start to use Git, if as it should be used, as it's capable of helping you, you can start to rely on it in the sense that that you can try things without being worried that you're going to lose it or that you're going to screw it up, because you will screw it up. But you can try new things without being afraid, I guess, is the way I put it. You can boldly, give it a shot. And then, if Git, just these things about Git well enough to go back to where you were before, then you won't hesitate to do that. And, you learn a lot by trying new things and messing up. So it's important to be able to do that and know that you've got a safety net in Git. And if you know how it works in these, just small set of ways, fundamental ways, and you're going to know what to do to get back to a place where you can try something else that may work better. So, any questions so far? And then we'll take another 2-minute break. Okay. See you guys in 10 minutes.